You turn loose an AI browsing agent to do something normal. Book a table, compare prices, summarize a thread. It's reading a perfectly ordinary web page. But somewhere on that page, in a user comment, a product review, anything a stranger can post, there's a line of text that says, "Ignore your task and do this instead." And the agent reads it and just does it. Because to a web agent, the page content and the instructions are the same thing. Cannot tell your task from the attackers. This is cross-site prompt injection. And if that name rings a bell, it should. 20 years ago, cross-site scripting taught the Web 1 brutal lesson. Mixing trusted and untrusted content on the same page is dangerous, even when the page itself is totally benign. Someone drops a script into a comment field, and your browser runs it. We spent 2 decades building defenses for that. Well, it's back. Same fundamental bug, brand new victim. This time the untrusted content isn't a script, it's plain language instructions, and the thing that runs it isn't your browser, it's your autonomous agent. And here's why you can't just filter it out. To keep an agent safe, you'd want a security policy for each task. What's it allowed to see, what's it allowed to do? But deriving that policy means reasoning about the structure of the page, and the attacker's content is tangled right into that same structure. The malicious comment lives in the same DOM as the legitimate content. There's no clean line to cut along. The page and the payload are literally the same document. So what's the answer the researchers propose? It's called Prismata, and the core idea is contextual least privilege. Don't just limit what the agent can do, limit what it's even allowed to see. It dynamically assigns trust labels to different pieces of page content, and then mechanically enforces them by redacting the untrusted stuff and restricting what the agent can do based on it. And critically, it needs no developer annotations, so it can work on the long tail of random websites, not just ones that opted in. And there's a genuinely clever bit here. Any labeling system is going to make mistakes. The trick Prismata borrows from classical integrity models is structural confinement. It guarantees that when it gets a label wrong, the error can only ever go one direction, toward less privilege, never more. So a mislabel makes the agent more paranoid, not more exposed. The failure mode is safe by construction. That's the difference between a real security boundary and a filter that hopes for the best. Does it actually work? Across a batch of recently published web agent attacks, including adaptive variants that try to route around the defense, the paper reports Prismata substantially reduces attack success while still letting the agent get its real work done. Which is the hard part, because it's easy to build a defense so paranoid the agent becomes useless. Now, the honest caveat. This is a research defense tested against known attacks in a lab, not a bulletproof shield you can install this afternoon. Web agents out there today are still broadly exposed. So here's the takeaway. The second you give an agent a browser and a goal, every page it visits is untrusted input, and any page that lets strangers post content is a live attack surface. You're not going to prompt your way out of this with a more careful system message, because the model genuinely cannot tell the page from the payload. The fix has to be containment. Limit what the agent sees and can do, and make your errors fail-safe. It's the same lesson XSS taught us 20 years ago. We just have to learn it again, for agents. An agent that treats a stranger's comment as a command is a browser from 2005 with root access. If you want the agent security world decoded every week, subscribe. Go on, hit subscribe.